Yo, Coach Ray's back with another video for you on linear inverses. Yes, before we get started, don't forget to like, subscribe, share, push notifications. You know the deal. All right, linear inverses. I tried very hard. I hope I was successful in emphasizing a sentence very much so on this screen. Okay. Whenever you hear the word inverse in this class, this red sentence should pop into your head. Okay? There are two parts of this sentence. Part one says switch x and y. That's the first thing that you're going to do whenever you're doing inverses. Okay? The second thing you're always going to do is then solve for y. Always, always. Doesn't matter what unit we're in. Okay? This red, bold exclamation points at the end sentence should always be what pops in your head whenever you see the word inverse. All right. So let's see what it looks like. Example 1 says find the inverse. F of x, so this is in function notation. F of x is the same thing as y. So y equals 2/3 x minus 6, basically. And the step 1 to finding an inverse is to switch x and y. So now I'm going to take f of x, which is y, and I'm going to change it to x, equals 2/3 y minus 6. So if I ask you to find the inverse, the first thing you always do is just switch x and y. Once you have x and y switched, just do the other part of your giant red sentence, solve for y. Okay, so I've got to get rid of two things. I've got to get rid of plus 6, I've got to get rid of this minus 6 in the back, and I've got to get rid of the 2/3. Since the 2/3 is multiplying by my variable, I'm going to get rid of my constant first. So the first thing I'm going to do is I'm going to do plus 6 on both sides. All right, x and 6 are not like terms. One's a variable, one's a constant, so I just write them both down. X plus 6 equals 2/3 y. All right, in order to get rid of a fraction, hopefully you remember from Algebra 1, you multiply by an R word. That R word is reciprocal. Okay, so if this is 2/3, if I flip it, that'll give me the reciprocal. I can try to squeeze it in somewhere, but I'll just write it in the back here. I'm going to multiply this side, oops, not by 2/3. I'm going to multiply by the reciprocal, which will be 3/2. Okay, common mistake, super common mistake. When we do the same thing on the other side, you have to do it to every term over there. There's a couple different ways I could write it. I could put parentheses around my x plus 6 and just put my 3/2 outside. That would show I need to do distributive property. Okay, so I'm going to write it like that. I could also just write 3/2 times x and then squeeze in there somewhere 3/2 times 6 because I do have to multiply it by both. All right. When it comes to dividing, same thing. If I were dividing on both sides, I would have to divide each term. That's a common mistake people make in algebra. All right. So now distributive property. 3/2 times x should be easy. That is just 3/2 x. All right. 3/2 times 6. I'm going to put my 6 over 1. Multiply straight across. So on top, I'm going to get 18. On the bottom, I get 2. 18 divided by 2 is positive 9. Okay, and my 2/3 is gone, so I just have y left over here. Okay, so I'm basically done. I'm just going to take one more line to kind of clean up and make my answer pretty. All right, so this is a good answer. It's just not pretty yet. One thing I'm going to do is I'm going to take my y and move it to the front. It looks way prettier up front. Okay. And the other thing I'm going to do is, since the problem was given to me in function notation, I'm going to write my answer in function notation form. If the problem was given to me as y equals, I would give it in y equals form, but this one is in function notation form. So notice how I write this. I put a little -1, looks like an exponent next to that f. So that's like f -1 of x. That is not actually any math. That is just a symbol. Okay? That symbol means that this is an inverse. Right? F of x is up top. Down here at the bottom, we have the inverse of f of x. And we can tell it's the inverse because we put that little -1. If it was y, instead of f of x, we would put y with a little -1 symbol up there. Same thing. Okay? All right. So anyway, I'm just going to write the rest of this down. I got 3/2 x plus 9. That's it. Finding the inverse just requires you to switch x and y and then solve for y. Okay, let me do example 2. Example 2, I'm going to tell you one way I could do this problem. I'm not going to do it that way because it's not the most efficient way to do it. But I still like to explain to you that you could do it this way. Okay, so checking out, this is what I'm talking about. I'm looking at this red line. and I know that I could write the equation of this line. Writing the equation of this line just means figuring out my slope, figuring out my y-intercept, and then I got y equals mx plus b. My y-intercept is right here, that's 3. Okay, so, and my slope I can see is just going down 1 over 2, so that'd be negative 1 over 2. So the equation of this red line is y equals negative 1/2 x plus 3. So what I could do is I could write that down, y equals negative 1/2 x plus 3. I could switch my x and y just like I did in example 1, and I could then solve for y doing all of this work right here. That is one way you could get the correct answer. Okay? Or, if it's on a graph, inverses are very easy to mess with on a graph. The only thing you have to remember with inverses in their graphs is you switch x and y, which is the same thing we did algebraically, but we can do it on a graph as well. So look at this first point. It tells me negative 4, 5. I'm not going to switch any signs. I'm literally just going to switch the x and the y spot. Okay, so that means 5 would become x, negative 4 would become y, and I'm going to plot that. So right 5 down 4 would be right down here. This point is 5, negative 4, and that is one of the points on my line of the inverse. Okay, next point, 2, 2, this green one here. If I switch 2 and 2, still the same thing, right? 2, 2. So that's going to actually be where they intersect. They both have that point. All right, this one, the y-intercept I didn't write in there. That would be 0, 3. So I can do another point. I can switch those and be 3, 0. 3, 0 would be over here. Okay. Anyway, the last point they have is 8, negative 1. So if I switch those two, I would get negative 1, 8. That point would be up here. All I'm doing is switching my x and y.
Oh.
Because in inverses on a graph, it's just all the x's and y's switched. Okay, so now I've got these points, I can just draw my line. How did I do it? Not bad. Alright, so that blue line is my inverse. Okay, I have to like kind of read the directions carefully. Did it ask me for the equation of the inverse? Not really, it just said find the inverse. That line is the inverse. So that would be an acceptable answer. If I asked for the equation, you'd have to go back and find the equation of that blue line, but we didn't have to do that in this one. So that's it. Inverses are just switching x and y and then solving for y. Or if it's on a graph, just switch your x's and y's on all of your points and you'll have your new inverse. Okay, the only thing I have left I want to show you is something on Desmos. All right, Desmos. I already have them up here, I think. I just want you to see this. The red line was the original line that we had up there. The blue line was my inverse equation. Okay, and what I did over here is you can see I plotted y equals x, which is just this diagonal line that goes right to the origin. Okay, and what I want you to see is every single inverse that has ever existed reflects across this line. Okay, so if I folded this board over at that green dotted line, it would land right on top of each other. Okay, so it just always reflects over that line y equals x. All right, so if you're ever not sure if two things are inverses, you can just graph them both and see if they reflect across that line. All right, that is it for